Hello students, welcome to my class. Today we are going to discuss few questions related to JEE main exam. Clear friend? As I told you earlier, this chapter is completely theory based, and if there is a simple some typical question, that is we will discuss this those typical questions in coordination chemistry, because coordination chemistry directly belongs to D block elements. So friend, let's start with the topic. Now question answer round. My first question, look at what I'm telling, that is ferromagnetic. As we know, magnetic property, ferro, anti-ferro, paramagnetic, diamagnetic. Do you remember this? In first chapter in solid state, we have discussed about the electrical properties and magnetic properties of the element. So how many magnetic properties are there? So paramagnetic, diamagnetic, ferromagnetic, ferrimagnetic and anti-ferromagnetic. And as I told you earlier, ferromagnetism is found in which metal of the 3D transition series? As I told you, Fe, canso ferromagnetic, cobalt, canso ferromagnetic, nickel, canso ferromagnetic. I have discussed this question in solid state also. So for this, D is the correct option, all of these. Clear friend? Now I am going to rub this part and we'll discuss the next question. The next question is question number 2. The intense purple color of MnO4 minus arises due to the absorption of visible light. What I'm telling, the intense purple color. As I know, for color there is two factors generally responsible. That is, first one is DD transition. Clear? If I talk about the MnO4 minus, that is KMnO4. Okay, sir. And this KMnO4, that is comes MnO4 minus. Here Mn is in +7 oxidation state. Clear to you what I'm telling? Mn is in +7 oxidation state, and in +7 oxidation state, that is 3d0, empty d orbital. So that means to say, according to the DD transition, this one is colorless. But still we find that KMnO4 has purple color. What is the reason behind it? So for KMnO4, there is another concept arises, that is charge transfer spectra. What I'm telling? Another, that is charge transfer spectra. Clear? And in charge transfer spectra, what will happen? The transfer of charge. So for KMnO4, DD transition is not a suitable concept to discuss, to prove the color of KMnO4. That is, in this case, a new concept arises, that is charge transfer spectra. Now moving here, look at which one, that is momentary transfer of electron from O2 minus to metal Mn +7. That is the charge transfer. So for MnO4 minus, that is which theory explain the color of MnO4? That is the charge transfer spectrum. So for this, D is the correct option. For question number 2, what I am telling, D is the correct option. Now friend, wait for a moment. I am going to rub this part and we'll discuss the next question. Now let's move to the next question. Which of the following is isostructural of Cr2O7? First of all, check it out. The first option, as I told about, that is the structure MOO minus Cr2O7, that is O, that is M, yes sir, then double bond O, that is O minus. This is the structure of Cr2O7. Clear? Put here Cr2, Cr, put also here Cr. Clear to you? Now compare which one has same structure like Cr2O7. If I talk about the first option, if I check the first option H2O7 2 minus, then what will happen? Check it out. Look at, if I draw the structure of H2O7, it has a structure like this, O minus. Clear to you? That is O, this one is S, O, then O, then O minus. Clear to you? This is the structure, that is H2O7. Clear? Now compare this structure, both have similar structure, and the question is isostructural. So as I told you, for JEE main examination there is only one option correct, so we do not need to check B, C and D, because which of the isostructure we get the first option, that is H2O7 2 minus have similar structure like Cr2O7 2 minus. So for this question, sir, it's very simple, A is the correct option. Clear, friend? Now I'm going to rub this part and we'll discuss the next section. Wait for a moment. Now let's move to the next question. What is the next question? Check it out carefully. Metal of D block which produce H2 with H2SO4 and NaOH both in separate test. As I know, there is a famous compound Zn. When treatment with H2SO4, remember this, it gives you ZnSO4 plus H2. This is the first. Now when Zn, when treated with NaOH, that is, it forms Na2ZnO2 plus H2. Clear to you? Okay, what I'm telling, Na2ZnO2 plus H2. In both the cases, Zn react with and release H2 gas, and the ratio of hydrogen liberation in both the cases 1 tends to 1. This is one of the best question. Wait for a moment. So for this question, we people can say D is the correct option. So for question number 1, we can say D. Wait for a moment, friend. D is the correct option. Clear? Now let's move to the question number 5. Now tell me, I am leaving this question for you. What is the question here? Tell me, friend. AgNO3 solution when treatment with sodium salt. These all are sodium salt. This is also a question belong to the salt analysis. Now white PPT, on standing it gives black PPT. Now identify sodium salt in the above reaction. So first of all, what we need to do? We have to check out the reactions, what will happen in this case. So let's start. Okay, that is, the first one is AgNO3 and treatment with sodium. I am taking the first option, that is NaCN. Yes sir, that is, it can be written like this, Na plus and Cn minus. It can be written like this, plus here and minus here. So it will form NaGCN. As we know, this is yellow PPT, or you can say pale yellow PPT. Clear to you? And the byproduct is in this case NaNO3. Here the question is, it gives white PPT, so definitely this is not a correct option because this is yellow PPT and in the question there is given white PPT. So this is not a correct option. Now let's check the second option, how to solve. Look at Na2CO3, yes sir, that is AgNO3. Now treatment with, that is Na2CO3. What will happen? Tell me. So it's very simple. That is, it will acquire plus charge, minus charge, plus charge, minus charge. That is Ag plus and NO3 minus 2Na plus and CO3 2 minus. Clear to you? Now what will happen? This will move here. That is the product is Ag2CO3 plus 2NaNO3, that is NaNO3. Clear to you? What happens here? That is Ag2CO3 and NaNO3. Put here 2, put here 2 also. Wait for a moment. Na2CO3, Ag plus and NO3. Now check it out that it gives you Ag2CO3, Ag. Put here 2, that is 2CO3. Put here 2, that is 4. Now here is 4 to Ag2CO3, 2Ag, and Ag is 4 times. Put here 4 and put here 4, that is 4NO3. Now Ag2CO3 has color, that is again this is a color pale yellow PPT, or sometimes it looks like, in many books it is given white PPT, but on standing it does not give, it dissolves. So it does not give black PPT. So this is not a correct option. Now let's move to the next one. Wait for a moment. Okay. Now let's check the next option. What will happen? Now the next option is given Na2H2O3. Now check it out. If I talk about AgNO3 and AgNO3 on treatment with Na2H2O3. Now what will happen? As we know, wait for a moment. AgNO3, that is, it will break like this, Ag plus and NO3 minus, and this one will break like this, 2Na plus and H2O3 2 minus. Clear? Now the product here is Ag2, yes sir, H2O3. Remember, I have discussed this question in salt analysis also, in my previous PPT solution also. This is white PPT, complete on standing, that is, it gives you Ag2S and H2SO4, and we all know this Ag2S is black PPT. So look at, first forms white PPT on standing, that is further reaction proceed and gives Ag2S, which is black in color. So for this, according to the question, that is the formation here Ag2H2O3 and black PPT, that is Ag2S. Clear to you? So in this case, third is the option. If I talk about, we do not need to check the last option still if you want, that is, as you know, sulfide ion Na2S, when it is treatment with AgNO3, we people know it forms Ag2S, direct Ag2S, that is, it forms black PPT. Clear to you? But first of all, what about the question? First of all, it will form white PPT, then black PPT. So definitely Na2S is not the correct option. So for this, we can easily say, we can easily observe that a C is the correct option. This question is one of the best question for JEE Main 2019. Clear, friend? Now I'm going to rub this part and we'll discuss the next part of the question. Now let's move to the next question. Next question is, when K3FeCN6 solution is boiled with Ki, look at what will happen. K3FeCN6, okay, when boiled with Ki, clear to you? Then what will happen? Then it will form K4FeCN6, yes, plus half I2. Clear to you? So in this case, look at what will happen here. that is -1 oxidation state convert to 0 oxidation state, and +3 oxidation state convert to +2 oxidation state. That is, reductions and oxidation take place. So this is a type of redox reaction, definitely redox reaction. And here the Ki, iodine, has increase is oxidation state. If there is an increment, that is, it act as a reducing agent. Clear to you? And if it is a reducing agent, then definitely it is a oxidizing agent. Clear, friend? What I'm telling, it is a oxidizing agent. Now check it out, which one option produce K4FeCN6. Yes sir, this is the K4FeCN6. Okay, produce I2. Yes sir, this all produce, first and second is correct. So redox reaction, definitely there is a change in both oxidation and reduction take place. So third is the correct option. Now we can, all are correct. So for this question, D is the correct option. All are correct. Clear, friend? Now I'm going to rub this part and we'll discuss the next question. Wait for a moment, give me few seconds. Now, next one, question number 7. Which of the following is correct order of oxidation number of metal? What I'm telling, correct order. So find out the oxidation state in each and every case. If I talk about TiCl3, X plus minus 1 into 3 is equal to 0. Yes sir, that is X minus 3 is equal to 0. X is equal to plus 3. For the first case, in case of TiCl3, Ti has oxidation state plus 3. Now if I talk about zirconium, that is O2 plus, that is X plus minus 2 is equal to plus 2. X is equal to plus 2 plus 2. X is equal to plus 4. In this case, the second case, the oxidation state is plus 4. Now moving here, check it out. That is RuO4 2 minus. RuO4 2 minus. Put here X. Then what will happen? Look at X plus minus 2 into 4 is equal to minus 2. Then X minus 8 is equal to minus 2. X is equal to minus 2 plus 8, and X is equal to plus 6 oxidation state. Clear? Now next one, Ti, okay. Plus 3, plus 4 and plus 6. It will have more oxidation state. Then there comes this, then there comes this. Now find out the correct order. That is TiCl3 plus 3. Then here plus 6. Now this is not a correct option. Now check out. This one is plus 6, plus 4, plus 6. This is the correct option. So for this question, what is the correct option? Tell me. Sir, B is the correct option. Clear? Now I'm going to rub this part and we'll discuss the next part of the question. Wait for a moment, give me few seconds so that we can easily solve such questions. Now let's move to the question number 8. Which of the following is correct order of basic strength? As we know, if I talk about the scandium, yttrium and lanthanum, that is the oxidation state plus 3, size, that is plus 3, it is also n plus 3. This is the order of size, and this is the order of ionic character, YOH whole thrice and LaOH whole thrice. Yes sir. So what is the basic strength character? Is very simple. As we know, if size increases, sometimes if we relate with the ionic character and metallic character also, and we know that is in this case basic strength increases. So what is the order for basic strength? That is SeOH whole thrice, then YOH whole thrice and LaOH whole thrice. This is the basic strength character. What I'm telling, this is the basic strength. This is the ionic, this is the size. Basic strength character. Okay. Now we people can easily observe for this, that is the option La Mo, okay, then Y, then Cs. So for this question B is the correct answer. Clear friend? Now let's move to the next part of the question, how to solve the question. Check it out. Now look at the next question. This is statement type question. What is given here? Actinoid contraction is greater from element to element than lanthanide cut. That is simple, is true statement, because first come lanthanide, then comes actinoid contraction. It is greater for element to element than lanthanide contraction. Okay, this is a straightforward question. This one is true statement. Okay. Now statement 2, the 5f electron themselves provide poor shielding from element to element. Yes, as we know in actinide there is an involvement of 5f electron, and for lanthanide responsible is 4f electron. So this statement 2 is also correct, and statement 2 defines the statement 1, that is explain the statement 1. As I told you, in lanthanide there is an involvement of 4f electron, and in actinide there is an involvement of 5f electron. So statement 1 and statement 2 both are correct, and statement 2 explain the statement 1. Now check out the answer. Statement 1 is true. Statement 2 is true. Yes sir. Statement 2 is a correct explanation for statement 1. Yes sir. For this question, that is A is the correct option. Clear? Now I'm going to rub this part, friend, and we'll discuss the next part of the question. Now next part of the question is question number 10. That is, the question is lanthanum, so plus 4 oxidation state. Yes. Okay. Now as I know, if I talk about the lanthanum, that is the plus 4 oxidation state is not common. In lanthanum, general oxidation state, as I discussed earlier, plus 3 oxidation state. So definitely we can say that this is not a true statement, false statement. After the loss of 6 and 5d electron, yes, 6 and 5d electron, because the electronic configuration is xenon 5d1 and 6x2, that is the general electronic configuration. So after the loss of 6s and 5d electron, it achieve inert gas configuration. Definitely if you lose 5d and 6s electron, it gets xenon is an inert gas. Okay, so statement 2 is a true. Definitely statement 2 is true. So now check out the statement 1 is true, not. This one is statement B was not, so not correct. See, statement 1 is true, no. Statement 1 is false and statement 2 is true. So for this question, D is the correct option. Clear to you? I think now you can easily solve such kind of questions, and it's completely theory based question. So boost up your knowledge with a solid theory. Follow my lectures, follow my suggestions. If you have any doubt, in each and every lecture I used to tell, if you have any doubt, you can easily approach to me. If you have much more, if you need much more explanation, then you can easily tell me. I am always here to help you. Now review the section. Now check out the again question. For question number 1, what is the option? So D is the option. FeCO and Ni all are ferromagnetic in nature. Yes sir. For question number 2, the intense purple color of MnO4 minus arises due to the absorption of visible light from, in this case as we know, no DD transition, in this case charge transfer. So D is the correct option. Now for question number 3, isostructural, that is H2O7 2 minus, A is the correct option. Metal of D block element, as I know, Zn is the simple explanation. AgNO3, as I discussed, Cn gives you yellow PPT, Na2CO gives pale yellow PPT or white PPT, but on standing it dissolves, no color changes. Na2H2O3, it gives first white PPT due to the formation of Ag2H2O3, and second it forms Ag2L. So C is the correct option. Clear? For question number 6, tell me this is an example of redox reaction. Ki is reducing agent and K3FeCN6 is oxidizing agent. So produce K4FeCN6 is correct option, produce I2 correct option, so redox reaction correct option. So all are correct. So for question number 6, D is the correct option. Now let's move to the question number 7. As I discussed, RuO4 plus 6 oxidation state, zirconium plus 4 oxidation state and titanium, that is plus 3. So option is B. Now for question number 8, which of the following basic stain, as I discuss you, LaOH all thrice, YOH all thrice and SCOH all thrice. B is the correct option. Now this one is very simple. 1 and 2 both statements are correct and 2 is the correct explanation of 1. So A is the correct option. For question number 10, as I told you, the general common oxidation state is plus 3 because the electronic configuration xenon 5D1 6S2 and statement 2 is correct, statement 1 is false, statement 2, so D is the correct option. I think now you can easily solve such kind of question. So friend, time to say bye bye. Thank you so much. We will meet again.